Alright, today we're going to be talking about square root functions and how to graph them. Our parent graph is y equals the square root of x. Our domain will be from 0 to infinity, and our range will be from 0 to infinity. Notice how the graph grows. Over 1 up 1, over 4 up 2, over 9 up 3, over 16 up 4. So let's talk about the general form. We have y equals a times the square root of x minus h plus k. A is our stretch or our compress value. Remember, inside lies, since the h is inside the square root, that moves us left and right, and it's always the opposite of the number we see there. And the number on the outside, k, is what moves our starting point up and down. So let's take a look at a problem here and just make sure we get the idea. We should be getting really good at this stuff. So we have the square root of x plus 5 minus 3. That means we need to go backwards 5 and down 3 to get to our starting point. Remember, we can't have negatives under the radical, so this changes our domain. So we put a dot there, and then we can go over 1, up 1, since there is no stretch factor. Then we can go over 4, up 2. And we can go over 9, up 3. And we can keep following that pattern as long as we have room to graph the ordered pairs. So our domain is from negative 5 to infinity. And our range, we have a low point at negative 3, and it goes up forever, so from negative 3 to infinity. So let's take a look at a simple problem here. Notice we don't have a stretch factor. We do not have a horizontal movement. We just have a vertical movement. So since our original starting point is at 0, 0, we'll go ahead and graph the parent graph here. 0, 0, up 1 over 4 up 2. That means we have to take that starting point and move it up 2 units. And then from there we go over 1 up 1. And then we go from the starting point again, we go over 4 up 2. So notice how these points are translated. And then connect our dots. And we can make our table. So now we can see our domain, it starts at 0 and goes to infinity. So the k value does not change the domain. Now the range, it starts at 2 now and goes up forever. So the k value changes our range. So let's take a look at another problem here. Notice we have a plus 3 inside the radical. The inside lies. So this means we're moving left 3 units as from our original starting point. So we have to move that point from 0, 0 back to negative 3, 0. And then from that point we go up 1 over 1, over 4, up 2. And if we have room we go over 9, up 3, which we do. Connect our dots. We can fill in our table. And we can see that our domain now has changed. It starts at negative 3 and goes forward forever. And our range has not been changed at all, so we still start at 0 and go up forever.
Hey guys, can you give me some functions?
What? I'm gonna do some math. Only got an 84 in my pocket. I'm graphing for some answers. We're gonna ace this project.
Welcome to class, like what up, I got a big funk. Yeah, when it comes to math, functions are a big chunk. X is domain, Y is your range. Functions like
Cousin, those Y's don't change.
linear identity, head into infinity. Sorta like constant, but angle kinda differently. Absolute value is basically the letter V. Put it in any X and it'll still come out positive.
Wow, guys, this is starting to make sense.
Got quadratic and cubic, raising the x to an exponent. If you plot them on a graph, then you're starting to feel confident. Put them in the square root and you're starting to get the opposite. Greatest common integer, those y's are only integers. I'ma teach you function style. I'ma teach you function style. No, for real, ask McGinnis, does she understand me now? The exponential growth and decay. Y equals AB to the x both ways. B's greater than 1 or B's less than 1. It's growth and decay, and that's how it's done. Hello, hello, put that x below. Do that and get 2 lines. Call that reciprocal. Put some polynomials in a fraction and graph those. The students would be all like,
Oh, that's just rational.
I'm gonna do some math. Only got an 84 in my pocket. I'm graphing for some answers. We're gonna do this project.
hey, I'm gonna do some math. Only got an 84 in my pocket. I'm graphing for some answers. We're gonna ace this project.
What you know about all the parts of a function? What you know about how they work in conjunction? You don't know? Then you gotta graph it on a calculator. Look at what you get and put the answers on the paper. You already know about range domains, so we can skip that absolute maximum. That's where your function peaks at. The minimum's the opposite. That's where it is the lowest. The point of inflection is right in the middle. Did you notice? X and your Y's, your A's and your B's, your F and the G's. All just some variables don't mean a thing to me till you put them in a graph and a shape is conceived. I got the funk, few tricks up my sleeve.
I'd be like, oh, that's concave, that's curving up. But wait, there's more. You're in luck. Intervals increasing, please don't ever stop believing. If you turn that issue around, then its interval decreasing. And behavior, don't sweat it, it's not a big thing. It's when x approaches infinity. It's pretty easy too. You really don't need that many other options. There's only a few. Graph game, come take a look at my 84. 0 when the function equals 0. Don't you know? Don't you know?
Functions. Poppin' graphs. Yeah.
Yes, sir. I'm gonna do some math. Only got an 84 in my pocket. I'm graphing for some answers. We're gonna ace this project. I'll copy your 84. Let's graph a little more. No matter where you go, functions you still gotta know.
Yeah.
I'll copy your 84. Let's graph a little more. No matter where you go, functions you still gotta know. Yeah, I'm gonna do some math. Only got an 84 in my pocket. I'm graphing for some answers. We're gonna do this project.
Is that all you know?
Damn right.
What?
So let's take a look at when we change that a value to a -1. Hopefully you guys remember when we looked at quadratics and absolute values that when we changed a to -1 it reflected over the x-axis. That's exactly what happens here again. So we just reflect all of our points over the x-axis. Now we need to look at this and think, does our domain change? Well, no, it doesn't. It still starts at 0 and goes up forever, or I'm sorry, right forever. But the range, notice now we have a high point instead of a low point. So our range is going to go from -infinity up to 0. Alright, so let's take a look at when we change that stretch factor to a value greater than 1. Notice we're doubling our horizontal movement in this problem. So instead of going over 1 up 1, we go over 1 up 2, over 4 up 4. So our domain doesn't change, and neither does our range from our parent graph, but the growth happens twice as fast. So let's take a look at a problem where we compress it. So the same thing, we multiply our vertical movement by that a value. So we're compressing our vertical movement by 1/2. Please use improper fractions. Notice this does not change the domain or the range. Okay, let's take a look at a problem where we just put everything together. So notice we got to go back 5, up 6, we're flipping it over and stretching it by a factor of 2. So we go over 1 down 2, over 4 down 4, over 9 down 6. And then we can write down our table if we need a table. And our domain, notice we start at -5 and go forward forever, so -5 to infinity. In our range we have a high point, so we're going to go down to -infinity up to 6, and including 6. Alright, the last thing we want to talk about is how to solve for the x-intercepts. Of course, we plug in 0 for y. So let's take a look at a problem here, and let's see if we can find the x-intercepts for this problem. We plug in 0 for y, then we have to ask ourselves, what do we need to do to solve for x? We subtract 2 from both sides, then we need to divide both sides by 2. Now we've got -1 equals the square root of x plus 3, so we need to square both sides to get rid of the radical. So now I have 1 equals x plus 3, subtract 3 from both sides, and we get x equals -2. Now since we squared, we created the possibility of extraneous solutions, so we need to double check this and make sure it works. So if we plug in -2, notice we get out 2 times the square root of 1, we get y equals 4. Does that work? No, it doesn't, because we should have gotten 0 back out for y. So there is no x-intercept for this. So let's take a look at another problem. Again, plug in 0 for y. Let's add 4 to both sides. And then we are going to need to undo the multiplication. So we divide both sides by 3. Now we need to square both sides. Remember, when we square a fraction, we square the numerator and the denominator. Now we need to add 2 to both sides. Get a common denominator. And we get x equals 34/9. So we need to double check this to make sure it works. So we're going to plug this back in and make sure we get out 0 for y. So again, we need to get a common denominator in order to subtract those. 16/9. Square root of 16/9 is 4/3. And 4 minus 4 is 0. So this one works.